Right. Okay. This Zoom session, a little belated, is being brought to you by the fractal heart of gold. All right, here we go. So today, I believe today we're doing sum and difference identities. Is that right, or did I cover that last time? I believe I did. Oh yeah, I believe I mentioned it last time. So here we go. Right, trig functions of a sum or difference of angles. So the book started with the cosine difference function, cosine of alpha minus beta. I'm going to do cosine of alpha plus beta first. Here's how it works. Imagine two circles, unit circles, with a couple points on each. This one is at cos alpha by sine angle, sine alpha. So it's at a positive angle counterclockwise from the positive x-axis. This is a negative clockwise angle beta from the positive x-axis. So this is a cos beta by sine of negative beta. Here, we take this triangle situation and rotate it counterclockwise by beta radians. So this is at an angle of 0 degrees. So here, this point is at 1 by 0. And this is at an angle of alpha plus beta degrees or radians. So it's at cos alpha plus beta by sine alpha plus beta. Now, since we're just rotating these two triangles, this distance here and here are the same distance. So d squared is the same. So this d squared equals this d squared, thus. And this d squared we take as a difference of, we use the distance formula. So d squared will be this minus this squared, cos alpha minus cosine negative beta all squared plus this. No. I'm sorry? Never mind. Sine alpha minus sine of negative beta all squared. Here, we take a sum of squares of differences, cos alpha plus beta minus 1 all squared plus sine alpha plus beta, that squared. Now then, there are a couple of things we do. Cosine of negative beta is cos beta. Sine of negative beta, the negative comes outside, so it becomes a plus sine of beta. Square will be square minus twice product plus square plus twice product plus square. Okay, so cos squared alpha minus 2 cos alpha cos beta plus cos squared beta plus sine squared alpha plus 2 sine alpha sine beta plus sine squared beta. Here on the left, it's cos squared of alpha plus beta plus minus, because of the minus here, minus twice cos alpha plus beta plus 1. And here's sine squared alpha plus beta. Now at this point, we get to use the Pythagorean relation. Cos squared plus alpha sine squared equals 1. So here's cos squared alpha plus sine squared alpha, put those together. Cos squared beta plus sine squared beta, put those together. Cos squared alpha plus beta plus sine squared alpha plus beta, put those together. And the other terms are here, 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 and here. So here's 1 plus 1 here, minus 2 cos alpha cos beta here, plus 2 sine alpha sine beta here, equals 1 plus 1 minus 2 cosine of alpha plus beta. These 1 plus 1s cancel out. Get minus 2 cos alpha cos beta plus 2 sine alpha sine beta equals minus 2 cosine of alpha plus beta. Okay, now we're nearly done. We divide both sides by -2. And we get the cosine of alpha plus beta equals cos alpha cos beta minus sine alpha sine beta. So cosine of a sum is cosine cosine minus sine sine. That's the cosine angle addition law. The cosine difference law, cosine of alpha minus beta, will simply substitute a negative beta in here and here and here. And because cosine of negative beta is cos beta and sine of negative beta is negative sine beta, you get the cosine of alpha minus beta equals cos alpha cos beta plus the negative flips to a plus sine alpha sine beta. This is the cosine angle subtraction law. If you substitute pi over 2 for alpha, and recall that cosine of pi over 2 is 0, and sine of pi over 2 is 1, then you get the cosine of pi over 2 minus beta equals sine beta. This is the complements law for sine and cosine, which we've seen before, but this proves it for general angles and not just acute angles. If we then substitute pi halves minus beta here and here, and since pi halves minus beta is beta, you get that this becomes cosine beta, this becomes sine of pi halves minus beta. So again, that's the complements law for sine and cosine the other direction. Okay, I mean, we already sort of knew that for acute angles. This generalizes it to all angles. Now, we can now find a sine of some rule. Sine of alpha plus beta, we'll write that as sine of a cosine of pi halves minus alpha plus beta by this law. And then we rewrite that as cosine of pi halves minus alpha minus beta. So now we have a cosine of a difference of angles. That will therefore get you sine of alpha plus beta equals cosine of pi halves minus alpha cos beta plus sine of pi halves minus beta minus alpha sine beta. And then using the complementary law again for here and here, cosine pi halves minus alpha is sine alpha, sine of pi halves minus alpha is cos alpha. So sine of alpha plus beta equals sine alpha cos beta plus cos alpha sine beta. If you substitute negative beta for beta, then in here, then this stays the same sign. The sine beta flips this to a minus. So sine of difference, alpha minus beta equals sine alpha cos beta minus cos alpha sine beta. Now already we gotten a fair number of laws. And just a second. So I'll summarize them here. Cosine of a sum is cosine, cosine minus sine, sine. Cosine of a difference is cos, cos plus sine, sine. Sine of a sum is sine, cosine plus cosine, sine. Sine of a difference is sine out cosine minus cosine, sine. Now you can also find rules for tangent of a sum. Since tangent equals sine over cosine, get the tangent of a sum is sine of sum over cosine of sum. The numerator is sine alpha cos beta plus cos alpha sine beta. The denominator is cos alpha cos beta minus sine alpha sine beta. Now for this fraction, we'll rescale numerator and denominator by cos alpha cos beta. All the cosines cancel, and all the sines become sine over cosine, which is tangent. Get sine alpha over cos alpha plus sine beta over cos beta over all that over 1 minus sine over cos, sine over cos. But these are tangents, and so tangent of alpha plus beta is tan alpha plus tan beta, all that over 1 minus tan alpha tan beta. And again, so that's a tangent of some rule. To find a tangent of alpha minus beta, we substitute negative beta for beta. Then this it becomes tan of negative beta, and negative comes out and flips this. Tan of negative beta, the negative comes out and flips this. So we get tan of alpha minus beta is tangent minus tangent over 1 plus tangent times tangent. Okay, so these are the angle, I put those here as well. So these are the angle addition and subtraction laws. Now we can, from this, determine cosine of sine and tangent of 75 and 15 degrees. We have rules for 30, 45, 0 degrees, for 30, 45, 60, and 90 degrees. The 15 and the 75 fit in the gaps in there, makes it a more regular thing. So cosine of 75. Well, 75 is 45 plus 30. So you have a cosine of 45 plus 30 degrees. So cos 45, cos 30 minus sine 45, sine 30. Okay, cos 45, that's isosceles right triangle with sides 1, 1, and root 2. And so cosine is root 2 divided by 2. Cosine 30, well, here's a 30, 60, 90 triangle with adjacent being root 3 and hypotenuse 2. So cosine of 30 is root 3 over 2. Sine of 45 degrees is also root 2 over 2. Sine of 30 is opposite over hypotenuse 1/2. Root 2 over 2, root 3 over 2 minus root 2 over 2 times 1/2. So after combining, we get root 6 minus root 2, all divided by 4. Sine of 45 degrees, well, that's 75 degrees. 75 is 45 plus 30, so you get, so use the sine formula, sine addition formula, sine cosine plus cosine sine, sine 45 cos 30 plus cos 45 sine 30. Sine 45 is root 2 over 2, cos 30 is root 3 over 2, Cos 45 is root 2 over 2. Sine 30 is 1 over 2, as again this triangle proves. And after a bit of arithmetic, that's root 6 plus root 2 over 4. Interesting complementarity between these two. For cosine of 15 degrees, well, that's 15 is a complement of 90 degrees, so that's really sine 75 degrees. Therefore, this root 6 plus root 2 over 4. Sine of 15 degrees is sine of the complement of 75 degrees, so it's cosine of 75 degrees, and therefore this root 6 minus root 2 over 4. All right, tangent of 75 degrees, well, 45 plus 30 degrees. Okay, so use the tangent addition rule. Tan 45 plus tan 30 over 1 minus tan 45 tan 30. Okay, tan 45 is 1, it goes here and here. Tan 30 degrees is 1 over root 3, goes here and here. So you get this mess. 1 over 1 plus 1 over root 3, all that over 1 minus 1 over 1 times 1 over root 3. Multiply top and bottom by root 3. After some denominators cancel out, you get root 3 plus 1 over root 3 minus 1. Okay, now to simplify this, we'll rescale, multiply top and bottom by the conjugate of the denominator. This is root 3 minus 1, so we'll rescale by root 3 plus 1. And after a bit of arithmetic, we get 2 plus root 3. Tan 15 degrees is tangent of the complement of 75 degrees. So therefore, that's the cotangent of 75 degrees, which is 1 over tan 75. So we already have that. That's 1 over 2 plus root 3. We'll rescale by 2 minus root 3. And after a bit of radical arithmetic, you get 2 minus root 3. Another complement, 2 plus 3 and 2 minus root 3. So some more questions. Prove that sine of 3 pi over 2 plus theta equals minus cosine theta. This is a phase relation. We shift the phase by basically 2/3, about 3/4 of a full cycle. That turns the sine into a minus cosine. Well, that's easy enough to prove. You use the sine addition rule. Sine of 3/2 plus pi, 3/2 pi plus theta equals sine cosine plus cosine sine. Sine of 3 pi over 2, 3/4 of the way around a circle, lands you at y value -1. So use -1. Cosine 3 pi over 2, rotate 3/4 of the way around the circle, lands you at x value of 0. So this is a 0. So you have a negative cosine theta plus a 0 is minus cosine theta, and that equals the right side, and we're done. Here is cosine of a difference. Arcsine 5/13 minus arctangent 3/4. Okay, so this is a cosine of a difference. So it's going to be cosine cosine plus sine sine. Cosine of arcsine 5/13, cosine of arctan 3/4, sine of arcsine 5/13 times sine of arctan 3/4. Okay, first for this, cosine of arcsine 5/13. Use this triangle here. This is a triangle, right triangle, with this side equal, with this angle equaling arcsine of 5/13. We do that by making the opposite side 5, the hypotenuse 13, and therefore by a bit of Pythagoras, we get that this adjacent side is 12. 5 squared plus 12 squared is 13 squared. So therefore, cosine of that, this angle will be 12/13. That's what we put here. Cosine of arctan 3/4. Here we use this triangle here, right angle here. This angle is arctan 3/4. So we had to achieve that by putting the opposite side be 3, adjacent side be 4. And by a bit of Pythagoras, this means this third side is 5, the 3, 4, 5 triangle. Cosine of that, this angle is adjacent over hypotenuse, 4/5. So far I have 12/13 times 4/5. Plus. Here, sine of arcsine just cancels, that's 5/13. Sine of arctan 3/4, well, going back to this triangle, here's arctan 3/4 angle. Sine of that is opposite over hypotenuse, 3/5. So this quantity equals 12/13 times 4/5 plus 5/13 times 3/5. And after a bit of work, that's 63 over 65. Okay. That concludes that.